Okay, so we're getting a little close to calculus here. This reminds me of the limit definition of a derivative in calculus. But basically, we have our formula for cosine of u plus v, and they just use it, and they show that that's true. And it seems arbitrary, but later on that'll be kind of more meaningful. In the meantime, it's just an example, but it does mean something in calculus. Okay, so we're going to do that down here. We're going to use our knowledge of these rules, and we're going to say, let's see, the tangent right here, the tangent of, so remember the top of the tangent, the numerator for the tangent is sine. So it's going to be, well, it looks like we distributed the tangent is what it looks like. And then on the bottom, we have 1, and this is the cosine's domain, so now we're going to say minus, and we're going to multiply, just because, you know, cosine's always kind of contrary. And then let's see, we're going to say 2 times the sine of, should I do this? Maybe I better do this. 2 times the sine of sine x cosine pi. We're going to keep the same sign, and we're going to say cosine x sine pi, because this is what we do. Okay. And I recommend the brackets to keep ourselves from making a mistake. So let's think about this. The tangent of pi. What is the tangent of pi? Well, when I'm at pi, pi's over here. When I swing over there, tangent is sine over cosine. And so that's 0. And that's 0. So that's all gone. That's going to make it look like I canceled the tangent, but I didn't. It's just 0. It's really 0. So tangent x over 1, well, it's hardly worth writing the 1, plus 2 times, let's see what happens in here. What's the cosine of pi? That's minus 1, right, over here? Cosine is about the x-axis, and over here it's minus 1. And what's the sine of pi? Well, that's 0, so that's gone too. So I have the sine of x, and oh, by the way, it's negative. Okay. So let's see, we say the tangent of x plus, well, not plus, we're going to say minus 2 sine x, and that's equal to 0. We're going to factor something out to make this work for us. So we're going to say, I know that the tangent of x is really the sine of x over the cosine of x, minus 2 sine of x equals 0. So let me factor out that sine. So I'll say the sine of x times 1 over cosine x minus 2 is equal to 0. Okay, so now I'm interested in 2 things. One, where is the sine of x going to be equal to 0? Well, where does that happen? Well, let's see. We say, well, it happens right away at 0, okay? And it also happens over here at pi, okay? Because sine is all about the y-axis, and so we're going to say x would be equal to 0 or pi, and I think our problem said we were supposed to stay between 0, including 0 and 2 pi. Yes, it did. Okay, so then the other situation comes in, and we say 1 over cosine x would equal to, if I want that to be 0, right? So, well, I don't want the cosine on the bottom, so I'm going to say, I'm going to switch places with the 2 and the cosine. So I'm going to say, where is the cosine of x equal to 1/2? Algebraically, I can say that. And I think, well, where does that happen? So I think, well, the cosine. That's the adjacent over the hypotenuse. Do I know any formulas like that for if this were the angle x? And maybe the square. I didn't draw it very well, but you know, I'll live with it. And I will say, oh, I know what opens up on that. X is going to equal pi over 3, 60 degrees. Wish I'd have made that a little taller, you know, a little taller. But anyway, and where else does that happen? Well, it also happens down here. If you'll permit me to talk about the coordinate axes suddenly, it also happens down here in quadrant 4. And also drawn poorly. But anyway, that would be 5 pi over 3 down there. Okay, so those are my 2 answers for where that happens. And if I plug that in and I put it underneath 1, I'm going to get half. So I'm referring to this, you know, if I plug this in there, the cosine of 60 is half, right? And it's underneath 1. Well, that's equal to 2. And then 2 take away 2 is 0, right? Just to be clear. Okay.